Okay, we are live. So, hey everyone, welcome to Practically We Bring Learning Alive. Okay, so as we all are aware that we have started this Term-2 one-shot series, correct? So, what are we doing with the series? What we'll be learning? We will be studying the entire chapter in one session, okay, and also solve some examples of it, correct? So I think we've done with two sessions. We are, especially in mathematics, we are done with polynomials and quadratic equations, quadrilaterals. So today we will be going with the topic of circles. All right. So what are we going to study in circles? What examples are we doing? What theorems are we proving? Let us see. Before that, let us see what is the schedule. So you all know by now, you must all be aware that the time slot for class 9 is from 6 p.m. to 8 p.m. correct? And these are the topics. Today is 11th February and we will be dealing with circles. Then tomorrow, not tomorrow, I'm sorry, on 17th February you will be having a session on gravitation physics, okay? Then we have construction, structure of the atom, work and energy, surface area and volume, and the last session is probability. Fun and learn. So fun and learn, if I'm not wrong, your name is Dheeraj, correct? Good evening, Dheeraj. So I am audible. Hi, Tushar. Okay. So these are the sample paper. We will be checking the sample papers later after the completion of one shot, okay? Next is the coding for class 9, that is computer science. We will be dealing with all these 4 topics and time slot is from 8 to 9:30 p.m. Okay? And these are the dates. Okay. So, circles is one of the most important chapter of class 9, correct? Because you will be dealing with the same chapter in class 10 as well. So, it'll and in your further classes. So we'll see what are we going to study about circles today. We will see introduction of the topic, components of circle, angle subtended by a chord at a point, perpendicular from the center to a chord, equal chords and their distances from the center, angle subtended by an arc of circle, cyclic quadrilaterals. So these are all the topics which we are going to study today. So without making it delay, let us start. So what is circle? What is circle? How do you define a circle? The collection of all points in a plane which are at a fixed distance from a fixed point in the plane is called a circle. Of course, correct? So what is the fixed point here? Center of the circle. So here this is center of the circle. And all these points on the circle are equidistant from the center. And what is that distance called? It is called radius of the circle, correct? So this distance, suppose let me name this as R. So OR is radius. So since we have checked radius, let us also see what's diameter. Hi Saraswati, I'm fine, thank you. How are you? So what's diameter? Let me draw diameter. Let me name this as E, this as A and B. So AB is diameter, correct? So these are the basic components of circle and also the definition of the circle. Now let us see what is chord of the circle. How do you define a chord? A chord of a circle is a straight line segment whose endpoints both lie on a circular arc. So now this is the chord, correct? Let me name this as PQ. So PQ is the chord. So in the line segment PQ, what are its endpoints? P and Q are the endpoints. And PQ both lie on the circle. So PQ is an example of chord. Next, segment. What is a segment? A segment is a region bounded by a chord. Bounded by a chord of a circle and the intercepted arc of the circle by the chord and the arc. So this is the segment, correct? Next, there are two kinds of segments, major segment and minor segment. Of course, right? So what is minor and major? We can just depict from the picture. This is a minor segment and this is a major segment. Correct? So this is about chord and segment. Next, sector. What is a sector? A circular sector, also known as circle sector, is the portion enclosed by two radii. Radii is the plural form for radius, and an arc where the smaller area is known as minor sector and the major portion is known as a major sector. So in this, let me name this as O, this is A, B. What are OA and OB? Come on, answer in the comments. What are OA and OB? So let's make it interactive, okay? I want answers from you. You all should answer so that I'll also get to know how much you're understanding the subject, correct? So just tell me what is OA and OB. No one? Are these radii? Of course, yes, right? OA is the radius, OB is the radius. So they are radii of the circle. So this part is known as minor sector, that is two radii and an arc. This is minor sector and this is major sector. Right, so now we have studied what is chord, what is segment, what is sector, and we have also seen what is minor and major sector, what is minor and major segment as well. Now, let us do a small exercise to test our knowledge, okay? A circle has only finite number of equal chords. Come on, answer. State whether the given statement is true or false. A circle has only finite number of equal chords. So, just answer in the comments. I'll check it. Hi, Ashok. Good evening. All right. So, come on, answer whether the first given statement is true or false. Hi, Shabana. Okay. So, what is meant by finite number of equal chords? So, it is, we'll have maybe fixed number of equal chords, but no, right? Given a circle, I can draw any number of equal chords. If I draw this, this is equal chord. If I draw this, so there are infinite number of equal chords. So this is false. Next, diameter is one of the chords. Is diameter one of the chords? Come on, answer in the comments. Can I say that diameter is one of the chords? I'll tell you an interesting point after this, only if you answer it, okay? Let's see who will answer. Okay, diameter is one of the chords, yes or no? Of course, diameter is one of the chords. This is absolutely true. Why? Let us see. So, let me take a circle. And what is the definition of a chord? The line segment where the two endpoints lie on the circle, correct? So, if we draw the diameter, let me just take this as center and this is PQ. So, PQ is the line segment where the ends are on the circle, correct? So, of course, PQ is the chord. It's also a diameter. So, of course, diameter is one of the chords and the given statement is true. Okay. Next, sector is the region between the chord and its corresponding arc. Is it true? Is it sector or is it segment? Hi, Aslam. Okay. So, region between the chord and its corresponding arc. Okay, let me draw a chord and this is the area, correct? What do we call this area? Is it segment or sector? Come on, answer it. We have just studied in our previous slide, correct? You have to remember, is this segment or sector? Okay. Alright, this is known as segment, correct? It is not sector. Sector is between two radii and an arc. This is sector. So this statement is wrong. It is false. Next, a circle is not a plane figure. Is circle a plane figure? Circle is a plane figure. Alright. So circle is a plane figure. So this statement is also false. Okay, so this is about the components of circle. Okay, yes, Aslam says it is sector. Yes, so this portion is sector, this portion is segment. Okay, I hope it is clear, everyone. So we have studied circle and also components of circle. Now let us move and see, and from here there are theorems. We have almost around 10 theorems, I guess, today in today's session. So we will be studying one by one. Few of them also have proofs, and there is a chance that you'll be getting proofs in your exam, correct? So Ashok says radius. What radius? Okay. All right. Okay, so let us start. So how do we begin with? Let us do a small activity. Let us take chords of different lengths and check central angles subtended by the chords. What exactly is central angle? The angle made by the chord at the center of the circle is known as central angle. Okay? What is central angle? Angle made by chord or arc at center of the circle is known as central angle, correct? Now what are we doing? Let us take chords of different length. So let me take this as AB, and in the next one let me take a bigger chord, or the chord which has a greater length. Next, one more. So X, Y. So here we are seeing three different conditions where the length of the chord is different, correct? So in this AB is less than PQ is less than XY, correct? So length of AB is less than PQ is less than XY. Now let us see the central angle. So this is O, O and O. First let us see the first condition. So this is the central angle, correct? In the next, this is the central angle, and in next, this is the central angle. Now if you observe these three figures carefully, what do you depict? We see that as the length of the chord keeps increasing, the central angle is also getting increased, correct? So if I name this as angle 1, angle 2, angle 3, then angle 1 is less than, angle 2 is less than angle 3, correct? So what do we depict from this? As chord length increases, the central angle also increases. Okay? So with this, let us see a theorem. Equal chords of a circle subtend equal angles at the center. Okay? Let us see also the proof for it. So here there is a circle given, and AB and CD are the chords, correct? Given AB is equals to CD. Why? Because equal chords. What do we have to prove? We have to prove that angle AOB is equals to angle DOC, right? To prove that angle AOB is equals to angle DOC. Now let us see the proof. So how do we start? Let us take these two triangles which you are seeing in the figure. So in triangle AOB and triangle DOC, we will be seeing if they are congruent. If they are congruent, we know that corresponding parts of congruent triangles are equal, and hence we can prove that these two angles are equal, correct? So now can you all tell me which congruency I can use for this? Type in the comments which congruency I will be using to prove this. Okay, I'm waiting for your answers. So please do answer in the comment sector. Okay, sector. Okay, Ashok says sector. All right. Okay, let us see what we'll do. Okay. Now, in triangle AOB, this triangle, and in triangle DOC, I know that AO is equals to OD, correct? Or AO is equals to DO. Why? Because it is the radius of the circle, correct? So, this is side. This is a radius. Next, again OB is equals to OC. Why? Again it is the radius of the circle and we know that all radii are equal, right? So OB is equals to, all right, let me just write this again. OB is equals to OC. Side, it is also the radius. And we are also given that chords are equal. That is AB is equals to CD, correct? So let me write AB is equals to CD, which is also side and it is given. So which congruency are we using here? We are using SSS congruency. So if we use SSS congruency, we can prove that these two triangles are congruent. So let me just take, okay, there is no slide. So by SSS congruency, these two triangles are congruent. So triangle AOB is congruent to triangle DOC. And what do we know about CPCT? That is, corresponding parts of congruent triangle are equal, correct? So by CPCT, angle AOB is equals to angle DOC. Hence, we have proved that equal chords of the circle subtend equal angles at the center. Hi Mayur. Alright, SRH dude, he has given some answer and then he deleted it. Alright. Okay, so this is the proof of the given theorem and you have to remember this is a statement because it will be used in the further problems. What is it? Equal chords of a circle subtend equal angles at the center. Okay. Next, the converse of the theorem is also true. What is meant by converse? That is the reverse of the theorem. What does it say? If the angles subtended by the chords at the center are equal, then the chords are also equal, correct? So again, if we take, okay, now this is A, O, B, P, O, Q. Now it is given that this angle is equals to this angle. Okay. Hassan, ma'am, can you repeat again? Okay, I'll repeat again. So, we have just seen first theorem. What is it? Equal chords of a circle subtend equal angles at the center. So, here we have the picture. What is given to us? That is AB is equals to CD. That is chords are equal. What do we have to prove? To prove that angle AOB is equals to angle DOC. Now, what are we considering? We are considering these two triangles and we'll check if they are congruent. So, they are congruent by SSS congruency. How? Because OA is equals to OD, which is radius. OB is equals to OC, again radius, and it is given that these two chords are equal. So by SSS congruency, that is side congruency, we say that these two triangles are congruent. And we know CPCT, that is corresponding parts of congruent triangle are equal. So by CPCT, we say that angle AOB is equals to angle DOC. Alright, so this is how we have proved the theorem that equal chords of a circle subtend equal angles at the center. Okay. Next, so now we are seeing the converse of it. What is meant by converse? The reverse statement. Okay, what is it? If the angles subtended by the chords of a circle at the center are equal, then the chords are equal. So given that this angle is equals to this angle, so this is radius, so by SAS congruency again, we can prove these two triangles are congruent. Again by CPCT, we say that AB is equals to PQ. So the converse of this statement is also true. So if the angles subtended by the chords of a circle at the center are equal, then the chords are equal. So Hassan, did you understand? If you still have a doubt, please do type in the comments. So I'll be happy to help. I'll be happy to explain again. So yes, let me just see so that I can go to the next theorem. So is everyone understanding? Are you all following the session? Okay, Hassan, very good. All right. So that first theorem is done. Second theorem is also done. The converse. Let us solve a question. Okay. Prove that if the chords of congruent circles subtend equal angles at the center. But what is meant by congruent circles? That is, circles which have same radius are known as congruent circles. Okay. So this is same radius. Next, what do we have to prove? Prove that if chords of congruent circles subtend equal angles at the center, then the chords are equal. Of course, we'll do it. So here are my two congruent circles. One is center O, next is center M. Okay. So there are chords. Okay, just let me draw this again. Yes. So it is given that they subtend equal angles at the center. So this angle is equals to this angle, right? Now we have to prove that AB is equals to PQ. What is given? Given they are two congruent triangles, that is they have the same radius. So AO is equals to PM, correct? Why? Same radius. Next, it is also given they subtend equal angles at the center. So angle AOB is equals to angle PMQ, correct? Now what do we have to prove? To prove that AB is equals to PQ. Of course, we have to use the congruency again. But what congruency we will be using so as to prove this? Let us see. Okay. So now here AO is equals to PM. Why? Same radius, correct? So AO is equals to PM side. Next, angle AOB is equals to angle PMQ. This is angle. Next, again OB is equals to MQ. OB is equals to MQ. Why? Radius. So this again side. So by SAS congruency, we have proved that by SAS, triangle AOB is congruent to triangle PMQ. Correct? Once we have proved that these two triangles are congruent, using CPCT, we can easily tell that AB is equals to PQ. So by CPCT, AB is equals to PQ. Right? I hope you have followed. So this is hence we have proved that both chords are equal. Correct? Next. Okay, yes ma'am, we are following. Okay, very good. Okay. I know that this is a chapter where you cannot give answers directly. Correct, but if you have any doubt, you please type in the comments, okay? Because here there are so many proofs, so you can't type the whole solution in the comments, correct? So yes, if I'll ask you a few questions in the middle of the proof or in the session, so please try to answer it, okay? The theorem 3, perpendiculars from the center to a chord. We know what is the chord. What is perpendicular? The perpendicular line, or you can say the perpendicular distance from the center to the chord. The line drawn through the center of a circle to bisect a chord is perpendicular to the chord. Okay, so what is given to us? It is given that AB is a chord. That's it. And to bisect a chord, that is AM is equals to MB. AM is equals to MB. Now again, what is meant by bisecting? It is dividing into two equal halves. So here it is given that bisect a chord, that is OM is bisecting the chord, that is AM is equals to MB. What do we have to prove? We have to prove that angle OMB is equals to 90 degrees. That is, we have to show that it is perpendicular. Correct? So how do we prove it? Let us again take in triangle AOM and BOM. In triangle AOM and triangle BOM. Okay. So now tell me again what congruency I can use to prove these two triangles are congruent. So this question you can type, right? So just type the answer in the comments. I'll check. Okay. By the time I'll be solving it, but you please comment which congruency can be used to prove it. Okay. So in these two triangles, let us see what do we know. We know that OA is equals to OB. Correct? OA is equals to OB. Why? Because they are radii. This is side. Next, AM is equals to MB because it is given. So AM is equals to MB. Again, side. Next, OM is equals to MO. Why? It is common. Again, side. Okay, Sarich dude, SSS, very good. By SSS congruency, very good. Keep it up. So, by SSS congruency, we say that triangle AOM is congruent to triangle BOM. Alright. So, by CPCT, I can say that angle OMA is equals to angle OMB. Angle OMA is equals to angle OMB. Now again there is a question. Observe carefully. What do this form? Angle OMA and angle OMB. What will be the sum of these two angles? You can easily tell actually. So just look at the picture and tell me what will be the sum of angle OMA plus angle OMB. You can just type the numerical, no issue. No need of degrees and all. I'll understand. 90. No, the bindu okay, bindu I'm repeating the question, okay. What will be the sum of, yes, sum of angle OMA plus angle OMB. SRH truth says 180, very good. It is 180 degrees, correct? Because till now we haven't proved that the angle is 90 degrees, so we cannot comment on it. We are proving this theorem, right? So, I can tell that angle OMA plus angle okay, this is plus, OMB is equals to 180 degrees. Why? Because a linear pair. Or it's a straight line, correct? So, but we already proved that OMA is equals to OMB. So, I can say that 2 of angle OMB is equals to 180 degrees, which is nothing but angle OMB is equals to 90 degrees. Hence, we have proved that the line drawn through the center of a circle to bisect a chord is perpendicular to the chord. Okay. So, yes, this is what we have proved. So, OMB is equals to 90 degrees and OMA is also equals to 90 degrees. So, this we have proved 90. If this is 90, this will also be 90 degrees. Right? Okay, now let us see if the converse is also true. Of course, the converse of the theorem is also true. The perpendicular from the center of the circle to a chord bisects the chord. So, if you are given a perpendicular from the center to a chord, always fix or always make sure, always be sure that it bisects the chord. Okay, so this is the converse of the theorem and this is also true. Okay, so did you all understand the theorem and the congruency which we have used for it? Are you all following it? Okay, Bindu, did you understand now why is it 180 degrees and not 90? Okay. All right, good. So next, let me move on to the next. Circle through 3 points. Now you might be wondering, what circle through 3 points? What are we doing? So first, let me take one point P. Okay. How many circles can I draw through this one point P? Can I draw only one circle, or can I only draw 2 circles, or can I draw infinite circles? I can draw as many circles as I want, correct? This is one circle, this is one circle, this is one circle, again this is one circle. So I can draw as many circles as I want through one point. Let us take 2 points, P and Q. So now tell me how many circles I can draw with these 2 points, which can pass through these 2 points. Come on, answer it. Is it only one circle, or is it only 2 circles, or 3 circles, or many circles? Okay. Come on, answer in the comments. Okay, I can draw many circles, correct? So I can draw like this, like this, like this, right? But what about 3 points? First, let me take the condition of collinear points, okay? So what is meant by collinear points? That is, all the 3 points are in a straight line, okay? So let me name this as A, B and C. So let me just draw a circle. So here if you observe, if I draw one circle, it cannot pass through all the 3 collinear points, correct? One point is left outside. Otherwise, let us draw, okay, wait. Yes, so let me draw this. One is again left, correct? So through 3 collinear points, we cannot draw a circle which passes through all the 3 collinear points, okay? But what about non-collinear points? Let me just take these 3 points, P, Q, R. So let me draw a circle. So there is only one circle which can pass through all 3 non-collinear points. Pass through 3 non-collinear points. Okay, so this is just a statement you have to remember. Next theorem. Of course, there is one and only one circle passing through 3 given non-collinear points. So here, let us take ABC points or anything else. You can just take P, Q, R, correct? So these points P, Q, R are non-collinear points, and we have drawn a circle which passes through all the 3 non-collinear points. But what if PQR is a triangle and you have drawn a circle? This circle is known as circumcircle, and the center is known as circumcenter, and it is known as the radius is circumradius. Okay, these are just the points you have to remember. This is circumcircle of the triangle ABC, or okay, let me name this as PQR, anything else, and its center and radius are called circumcenter and circumradius. Okay, this is just a point to remember, nothing else to prove in this. Next, equal chords and their distances from the center. Okay, inverse of this image is known as ES. Very good, Lakshmana Prabhu, you have given us the new point which is in center and Encircle, very good. When you draw a circle or when you inscribe a circle inside the triangle, it is known as encircle. Okay. So, okay, let us see that also since we have come across. So, this is the triangle. So, this, okay. I'm very bad at drawing, so please excuse me for that. This is an encircle. Okay. All right. Now, equal chords and their distances from the center. So, let us do a small activity. What do we have to do? So, let me just take a line and a point somewhere here. Okay, that is point A. Now, I am just drawing all these line segments. And this is 90 degrees. Let me name this as M, this as N, this is O, this as L. Now tell me, if I want to ask you the distance between point A and line PQ, what will you tell as the distance? Type in the comments. What is the distance between point A and the line PQ? Just name which line segment is the distance. Okay. Is PAL the distance, AO the distance, or AM the distance, or AN the distance? Of course, only AM is the distance, or AM is a perpendicular distance. Why? When it is perpendicular, this is like the shortest distance as well, right? So we say that AM is distance, or AM is perpendicular distance, correct? So now we know what is perpendicular distance. Let us see how it helps us in chord and circles, correct? Yes, SRH2 AM, very good. Next, the length of the perpendicular from a point to a line is the distance of the line from the point. So the length of the perpendicular from a point to the line is nothing but the perpendicular distance. Okay. So again, what is the perpendicular distance in the given figure here, circle? Here we have a circle with center O, and AB is the chord and OM is the perpendicular distance. So we say that OM is the distance of the line from the point A to AB, correct? Now we are aware, it is just OM is a perpendicular distance. Alright, next. With this, we will see what theorem we have to study. Chords equidistant from the center of a circle are equal in length. Okay, chords equidistant from a center of a circle are equal in length. All right. So for this we don't have proof. We have proof, but then that is not. Yes, that is not given in the exam. So let us just confine ourselves to this. Okay. Let me draw this circle again because they did not appear as a circle. So let me draw a circle with center O. What is it saying? Chords equidistant from the center. Okay. These are my two chords and this is equidistant. So OA is equals to OB. This is X, Y, this is Z. The chords equidistant from the center of a circle are equal in length. Lakshmana Prabhu says, in a chord, perpendicular line bisects the chord into two equal parts. Yes, of course, that is also a theorem, correct? So, yes, you can also remember it as a property of the circles, alright, because they'll be useful for problems. And as you remember, I don't know if you remember, but in the NTSC session when we have done circles, we have used all these properties, correct? So it's better to remember all the theorems of circles as properties of circles so that you'll be able to, solve many problems. Okay, correct. So given that OA is equals to OB, so since it is distance is perpendicular, so if this distance is equals to this distance, then XY is equals to YZ. And what about the converse of this theorem? Is that also true? Of course it is true. Equal chords of a circle are equidistant from the center. So if I take any two chords of the circle which are equal in length, they are equidistant from the center. Okay. So let us see how. So again here, let me just draw a circle. This is AB, this is center O, and this is chord XY. Okay, so I know that AB is equals to XY. So if AB is equals to XY, this is M, this is N, then OM is equals to ON. Okay, so equal chords of a circle, of course AB is equals to XY, are equidistant from the center, so OM is equals to ON. Okay, again this is also one of the properties, and there are no proofs for it. I mean, in the portion it is deleted, so I'm just not going for it. Okay, but let us solve a problem where we see the theorem, where we apply the theorem. Okay, so if two intersecting chords of a circle make equal angles with the diameter passing through their point of intersection, prove that the chords are equal. Okay, again this is one of the most interesting problems, correct? So now PQ is the diameter, correct? So first let us write what is given. Let me use another coloring. Yeah. So given that PQ is the diameter, PQ is diameter, and what else it is given? They make equal angles with diameter, that is angle LEO. Angle LEO is equals to angle MEO, correct? Is equals to angle MEO. Okay, next, what else do we have in the question? We have to write two intersecting chords. Okay, circle make equal angles. Yes, we have written with the diameter. Okay, PQ is the diameter passing through their point of intersection. Prove that the chords are equal. Okay, so now what do we have to do? From the center O, drawn OL and OM. What are these? The perpendicular distance, correct? And we also know that if it is perpendicular, it makes 90 degrees, right? So now let us consider in triangles OLE and OME. OME. Okay, so let us start solving. What do we know? Angle LEO, angle LEO is equals to angle MEO. Why? Because it is given, correct? This is angle. Next, if this is 90, this will also be 90, correct? So angle OME, OME is equals to angle OLE is equals to 90 degrees. This 90 degrees is not usually needed, but just I am writing so that you will understand why did we take these two angles. Next, OE is equals to EO. Of course, common side, OE is equals to OE or EO. This is side. So by AAS congruency. So let me just go to next slide. By AAS congruency, what can we write? Triangle LEO is congruent to triangle MEO, right? So we have proved that these two triangles are congruent. But what do we actually have to prove? We have to prove that the chords, that is AB is equal to chord CD, correct? Let us move to the next step. So by CPCT, I know that OM is equals to OL or OL is equals to OM. And what are these? Perpendicular distances. And we have studied in the theorem that chords equidistant from the center of a circle are equal in length. So by theorem 6, we say that AB is equals to CD. Why? The distances from the center, the perpendicular distances from the center to the chord are equal. So their chords will also be equal, right? So we have used this theorem to prove this. And yes, we have proved that chords are equal, that is AB is equals to CD. Okay, this is a lengthy question, I guess, a little bit lengthy to apply the congruency then theorem. So I hope you have understood. Is the question clear? Did you understand the solution for it? Okay, so if you are good, if you're not, please do ask your doubt in the comments. Okay. And if you like the video, please do like it and also share it with your friends and subscribe to the channel. Okay. All right. So is everyone following? No one is, I not ask any question, but still, is everyone following the session? So type in the comments and also type when are your exams, because yesterday I asked the same question and one told they have from February 28th. So when do you have your 9th class final exams? And when is your 10th class going to start? So do type so that we'll plan some course for you. We'll see what to do. We can do some bridge course. So if you type in the comments, I'll know if your exams are done or if your exams are not done. Okay, yes, so your exams are done. Okay. What about others? Okay, it's clear. Alright, I'm still waiting. If your exams are done, do let me know it's done, okay? But when are your exams? Just type in the comments if it is not done, okay? Alright, let me just go to the next topic. Angle subtended by an arc. So what is angle subtended by an arc? End of the month, okay? You have exams in end of the month, good, prepare well. Alright, so let me just name this first. This is AB, this is PQ, XY, MN, anything you can take. This is MN, this is O, this is also, let me take O. Okay. So here, what do we have to prove? Shritu Reddy, Shritu Reddy, very nice name. Done, ma'am. Okay, your exams are also done. So when are your 10th class, when is your 10th class going to start, or when will they start teaching you 10th syllabus? So just let me know, okay? All right. So let us see. So now if I join this OA and OB, also joining OM and ON. Now I have to see angle subtended by an arc. Akki Reddy, Srinu, ma'am, my exams are from 21st of this month. Okay, you have from 21st of this month. Good. All the best for your exams. So please do watch, okay, watch these one shot, okay, so that will be a revision for you. And okay, fine, good. All the best and prepare well. So we know that if AB and MN are equal, okay, then, okay, if AB is equals to MN, then we know that angle subtended and same radii, correct? These two circles have same radii. That is, they are congruent circles. Not understand? Rahul, what did you not understood in this? Is there any topic which you have not understood? I'll wait for a minute. You can answer so that I'll explain you that again. Yes, what did you not understand? Okay, so I'll just start. So by the time you mention what you did not understand, okay, I'll be happy to help. Fine. So here both radii are same. That is, they are congruent circles. And given AB is equals to MN, then we know that angle AOB is equals to angle MON, which we have seen in the first theorem. That is, equal chords subtend equal angles at the center. But what about the equal arcs? Do they also subtend equal angles at the center? Of course they do. Because if MN is equals to AB, then this arc length is also equals to this arc length, correct? So even these equal arcs subtend equal angles at the center. So if two chords of a circle are equal, then their corresponding arcs are congruent. And conversely, if two arcs are congruent, then their corresponding chords are equal. Of course, yes. And Congruent arcs or equal arcs of a circle subtend equal angles at the center. So we have already seen in the theorem 1 that equal chords subtend equal angles at the center. So same goes with the equal arcs. Equal arcs subtend equal angles at the center. Okay. So Rahul, you did not mention still what you did not understand. I was actually talking about exams. So if your exams are done, just say that it is done and when your 10th will be started. And if your exams are not done, just type the date from when your exams are going to start. Okay, I mean the final exams. All right, sorry for the interruption. Okay, just let me wait for the students and let me begin. All right, okay. So is the screen visible clearly now? And I'm audible? Okay, so let me start, okay? So we have stopped at this theorem, correct? So the angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. So according to the statement given, how can I write this? I can write this as, okay, wait. I can write this as angle PBQ is equals to 2 times of angle PAQ, correct? So according to the statement, okay, yes, all right, fine. So according to the given statement, I can write that the center angle, that is this angle POQ, okay, let me just write it, POQ, is double the angle of PAQ. So according to the statement, I can write this in an equation form or in the presence of angle. Same goes with the other two cases as well. Angle POQ is equals to 2 times of angle PAQ. But how do we prove this? Let us see. So let us take one case first and understand so that it applies to all the 3 cases as well. All right. So let me take this. If you are able to see the figure, let me take in triangle AOQ. AOQ. Okay. So let me just draw this. Yes. So this is the exterior angle, correct? Angle BOQ is the exterior angle. So what do we know about in sum of opposite interior angles is equals to exterior angle, correct? So now we will be using the same property to solve this. Let me write angle BOQ is equals to angle OAQ plus angle AQO. Why? Because we know that exterior angle is equals to sum of 2 opposite interior angles. So I am here writing exterior angle property. Right? Now same goes with the other case as well. Angle BOP is equals to angle OAP plus angle OPA, Now this is my equation 2 and this is my equation 1. All right. Okay, so let me add these two. Angle BOQ plus angle BOP is nothing but angle POQ. Angle POQ. So add 1 and 2. Okay, all right. Yeah. So angle POQ. Now if we add these both, we know that these two are the radius, correct? So if these two are the radius, that is this is equals to this, so this angle is equals to this angle is equals to this angle, correct? So if I add these both equations, what do we get? We will be getting that this angle plus this angle is equals to 2 times of angle PAQ. So this is what is the proof. We have to use the exterior angle property, and base angles are equal, that is isosceles angle property, so as to prove the theorem. So now you would be wondering, ma'am, we have proved only in one case, but what about these two other cases? The same goes with these two cases as well. You have to just take exterior angle, and we know that it is the sum of two opposite interior angles, and using that we can prove it, correct? So we have proved that angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle, right? So the same applies to all the three cases as well. But there is one special case I want to discuss, which we can use in further problems. Okay, let me see what it is. This is a special case of angle in the segment, and given PQ is the diameter. Okay, very good. PQ is the diameter, O is the center, and I know that if PQ is the diameter, this angle will be 180 degrees, correct? This is 180 degrees. Of course, why? It is a line. What is the angle of a straight line? 180 degrees, correct? Now, if this is 180 degrees, what will be the angle PAQ? Let us find out. And if you know, do type in the comments what will be the angle PAQ. Okay. And according to theorem, what do we know? Angle POQ is equals to 2 times of angle PAQ. But what is angle POQ? It is 180 degrees. So 180 degrees is equals to 2 times of angle POQ. So PAQ, angle PAQ is equals to 180 by 2, that is 90 degrees. Okay. So when the diameter is subtends an angle at any point on the circle, this angle will be 90 degrees. Okay. This property will be again studying in the angle in a segment. We'll see it further. Okay. Next, angles in the same segment are equal. But how are they equal? Let us see again. So, for first, let me join this PQ. If I join this PQ, PQ is the chord and it divided the circle into two segments, one major segment and one minor segment, correct? So let me see how PAQ is equals to angle PBQ. Let us see. We say that, or to prove that, angle PAQ is equals to angle PBQ, right? How do we prove it? Let us see. I know that angle POQ is equals to 2 times of angle PAQ. Of course, yes, we have just studied in the theorem, and I also know that angle POQ is 2 times of angle PBQ also. So from equation 1 and 2, what we can conclude? From equation 1 and 2, I can conclude that angle PAQ is equals to angle PBQ. And here is the proof of our next theorem. Angles in the same segment are equal. Okay. Hi Tejish Kumar, how are you? Is this your first time in the session? Or at least in a mathematics class? Okay, so this is how we can prove that angles in the same segment are equal. Okay, next. So we are done with this theorem as well, and we are done with few properties of circle. But this cyclic quadrilateral is one of the most important topics. So let us see what is it all about. Cyclic quadrilaterals. A quadrilateral ABCD is called cyclic if all the 4 vertices of it lie on the circle. Okay, I know what is the quadrilateral, but what is a cyclic quadrilateral? Always remember, all the 4 points of the quadrilateral should lie on the circle, then you say that that quadrilateral is nothing but a cyclic quadrilateral. Okay. So here ABCD is the quadrilateral where its vertices A, B, C and D all lie on the circle. So we say that ABCD is a cyclic quadrilateral. Okay, next. So here's the theorem which we have to study. Sum of either pair of opposite angles of cyclic quadrilateral is 180 degrees. So what are opposite angles here? Angle A plus angle C is equals to 180 degrees. Angle B plus angle D is equals to 180 degrees. Correct? So always remember, in the cyclic quadrilateral, sum of opposite angles is 180 degrees, or you can say that sum of opposite angles is supplementary. Correct? So what about converse of the theorem? That is also true, of course. So if the sum of the pair of opposite angles of quadrilateral is 180 degrees, the quadrilateral is cyclic. So suppose you have a quadrilateral which is inscribed in a circle, and it is given that these opposite angles make supplementary angles, that is angle D plus angle B is 180 degrees. So you say that this is a cyclic quadrilateral. Okay. Hi Vaishali, how are you? Okay, so again I'm repeating, what is a cyclic quadrilateral? A cyclic quadrilateral is called cyclic, or a quadrilateral is called cyclic if all the 4 vertices lie on the circle. Next, the opposite angles of a cyclic quadrilateral are supplementary, that is, the sum of opposite angles is equals to 180 degrees. Correct? Next. So now we have studied the theorem, so we have to apply it somewhere, correct? Where do we test our knowledge? So let us solve a question. In the figure, ABCD is a cyclic quadrilateral in which AC and BD are its diagonals. If angle DBC is equals to 55 degrees, okay, angle DBC, this is 55 degrees. And angle BAC is 45 degrees. BAC is 45 degrees. Okay. Find angle BCD. So we have to find angle BCD. So how do we do it? Let us see. So now if you observe, CD is a chord, correct? And that side of CD is minor segment. This is a major segment, correct? Now I say that angle CBD is equals to angle DAC. Why? Because angles in the same segment are equal. Angles in same segment are equal. But it is already given that angle BAC is equals to 45 degrees and angle CBD or DBC is equals to 55 degrees. Okay, let us also write this as DBC only. Why confused? Correct? So if this is 45 degrees, this will also, 55 degrees, this will also be 55 degrees. Why? Angles in the same segment are equal. Correct? So using which theorem? This theorem. Angles in the same segment are equal. Now this is 55. So this angle BAD is equals to angle BAC plus angle CAD or angle DAC. So what is angle BAC given? 45 degrees. So 45 degrees plus what is angle DAC? 55 degrees. So write 55 degrees. What is 44 plus 55? 50 plus 40, 90, 90 plus 10, 100. So 100 degrees. So I know that angle BAD or angle A is equals to 100 degrees. But by cyclic quadrilateral, we know that angle A, angle A plus angle C is equals to 180 degrees plus angle C. But what is angle A? 100 degrees. So 100 degrees plus angle C is equals to 180 degrees. Angle C is equals to 80 degrees. That is what they have asked us in the question, that is angle BCD or angle C. That is angle BCD is equals to 80 degrees. Okay, so we have used the concept of two theorems here. We have applied two theorems. One is angles in the same segment are equal and the other one is a cyclic quadrilateral. That is, opposite angles in a cyclic quadrilateral are supplementary to each other. Right? Next. In the figure, angle ABC is 69, okay, degrees. Angle ACB is equals to 31 degrees. Alright. So, in triangle ABC, we know that sum of all the angles in a triangle is equals to 180 degrees. So, let us apply the same concept which we have been studying from 3-4 years, correct? So, in triangle ABC, angle ABC plus angle BCA plus angle CAB is equals to 180 degrees. But what is angle ABC? 69. 69 degrees plus angle BCA or ACB 31 degrees, and we do not know angle CAB. So just put angle CAB is equals to 180 degrees. Correct? Hi Supriya, how are you? I hope you are doing well and preparing well for your exams. So angle CAB is equals to 180 minus, what is 69 plus 31? 9 plus 1, 10. 6 plus 3, 9, 10. So 100. So angle CAB, that is this angle, is equals to 80 degrees. We got this to be 80 degrees. Correct? So let us write this is equals to 80 degrees. But what do we have to find? We have to find angle BDC. How do we find it? We know that angle BAC, okay, here I am writing it. We know angle BAC is equals to angle BAC CDB or BDC. Why? Angles in the same segment are equal. Angles in same segment are equal. Correct? So, we know angle BAC or CAB is 80 degrees. So, angle BDC is also equals to 80 degrees. Okay. So, yes, this is what we got and we have found the angle BDC. Alright. So, I know there was some interruption during this session. I'm so sorry for it. But I hope you have understood all the theorems. So, whoever are watching, so please do comment if you have understood the theorems and these questions. Okay, and if you liked the video, please do like it. Also share it with your friends and do subscribe to the Practically channel. Okay. So, yes. Alright. So, we have seen the theorems and we have also applied it in few examples. Correct? Okay. So, this is it about today's session. So, on 17th February, you will be having a chapter on gravitation. Okay. So, please do come. It's a physics class you have and the time slot is same 6 to 8 p.m. You can even finish in 1.5 hours as well based on the length of the chapter. And this is for sample papers. We will thinking it to shift, but you will be knowing it sooner. And this is for computer science or coding, which is from 8 to 9:30 p.m. Okay. All right. Thank you, everyone. And yes, I have seen that few of them are having your exams from 28th or 21st. That is in this month itself. So, I hope this helps you because you just click one play on the YouTube, and then you will be getting a quick revision of the complete chapter of all math and science, correct? So yes, bye Supriya. So yes, thank you.